There we go.
Hi MOSI friends, my name is Urmila. Welcome to Virtual MOSI here at MOSI. Today we're in our STEAM lab and we are learning all about acids, bases, and pH. You can see I have a lot of stuff here and we're gonna go through that a little by little as we use it. If you try to do this experiment at home, and you definitely can, you can use almost anything that you can find in your kitchen, your garden, your bathroom, your makeup counter, many different places. So you have a lot of options to try this at home, or you can just watch with me here. It'll be a lot of fun. So what we're gonna be doing is testing a bunch of different liquids that we found at home to see if they're an acid or a base. The way we do that is to figure out what their pH is. So come on over here with me and we'll talk a little bit about what pH is. It turns out pH has a lot to do with water. So here's our water molecule. We know that water, the formula for water is H2O. So we have our two H's and our O. So when we just have a little beaker of water, or maybe a cup or glass of water at home, right? We just have a bunch of different water molecules like this. And they mostly stay like that. You get the idea. Our beaker is full of water. Once in a while, about 1 in a million or so water molecules actually is dissociated, which means it's separated. So instead of having the O with the two hydrogens covalently bonded, we actually have just a proton, which we write as H plus, and an OH minus. It turns out that when this happens, it changes the properties that the substance has. So when it's just water, there's very little of this dissociation going on. However, if we put an acid into water, you're going to have many more hydrogen ions, a higher hydrogen ion concentration. If we put a base in water, you're going to have a much higher OH minus or hydroxide ion concentration. And turns out that when we use these things in many different ways, in chemistry, in our own body, in gardening, in water testing, things like that, pH becomes a very important indicator. So our pH scale is up there, and that tells us the concentration of hydrogen ions in something dissolved in water. So for us to figure out pH, that something, that chemical, has to be able to be dissolved in water. If it has a very high H plus or hydrogen ion concentration, then we say it is an acid, and it's on the lower end of the scale. So let's write our acid right here. Right? If it has a very low concentration of H plus ion, we call that a base. So let's write our base over here. I'm going to erase this one. Right? And then the way we measure it, a very, very strong acid, like a 0 or a 1 or a 2, is going to have a pH of a 0, 1, or a 2. A very strong base might have a pH of 12, 13, or 14. We have an entire area in the middle here that's not a strong acid or a strong base. Those things are closer to being neutral. So let's write those. All right, so on our pH scale, we have a 7, which is neutral. Kind of looks like the cup of water that we drew here. We have an acid, which is towards the beginning of the scale, which is a 0, 1, all the way up to 5 or 6. And then we have a base, which goes all the way from 8 through 14. There are some super strong acids and bases that go even off our scale, but we're not going to talk about those today because you probably don't have those at home. So let's go ahead and get started with our activity. Take that off, put that back on later. All right, come on over this way. So how do we measure pH? There's a few different ways to do it. One way, we're going to do it two ways today. One way to do it is by using an indicator, and today we're going to be using red cabbage. It's a natural indicator. Another way you can do it is by using an actual device. So we also have a pH meter here that's going to give us a number representation of our pH. And then there's also other things you can use, like litmus paper that you might have heard of before. Litmus paper uses a form of lichen that's kind of imprinted on paper, and it changes color whether you put it on an acid or a base. Most people probably don't have litmus paper at home though. So today, if you want to try this at home, you can use our red cabbage, which we'll show you in a second. There's also a few other natural indicators as well that you might find at home or in your grocery store. Those include hydrangea flowers, roses, purple broccoli, blackberries. All those things can be natural indicators. So the reason that red cabbage works is because it has a certain molecule called anthocyanin in it, and it actually changes color based on whether we put it in an acid, a neutral substance, or a base. All right, so we'll see that in just a second, but first we need to make our red cabbage juice. So there's a few different ways to make it. You can just rip up pieces, put it in a container just like this, and then I'm gonna cover it with some boiling water. If you're gonna do it this way, then it is best to kind of let it steep for a little while until that liquid is a safe temperature for you to use. And then you can strain out all the cabbage, and the water, the juice that's left over is gonna be your indicator. So I have that, and I have some boiling water right here.
Mr. Mila, we have a question in the comments.
Sure.
Someone's asking, can you drink the red cabbage indicator?
Well, red cabbage is totally safe to drink, and boiling water is totally safe to drink. Our normal rule is, though, that you don't eat or drink anything in a chemistry lab. So I would say while you're doing the experiment and while you're prepping the experiment, you probably should not drink it. Later on, if you do want to have a little taste, it's up to you. I think it smells pretty bad though. I wouldn't drink it. But a lot of the stuff that we're using here is from your kitchen, so it's kind of safe to eat and drink. All right, so what we're gonna do is kind of leave that to steep, and we'll see a color change in just a second to let us know that it's ready. That's one way to make it. The other way to make it is if you just take some red cabbage. If you have really good knife skills, you can chop it up and mince it into really fine pieces, or you can use a blender and kind of blitz it, and then you don't need to use hot water. You can use room temperature water to get that purple out. So our end result is going to be this. We have all that anthocyanin taken out of the red cabbage and into a water solution. Right? So we don't really want the pieces of cabbage in there, but we do want our red cabbage juice. Let's see, so we have that ready. Let's talk about what liquids we're testing today. All right, I have a few different options that you can do at home. These are some things that I found mostly at home. So on this side here, we have what I call safe liquids, like red cabbage juice. These are mostly things that I found in my kitchen. So we have some milk, lemon juice, tonic water. I also have some bottled water. We already talked about lemon juice. There's some tap water there too. And then on this side of the table, I've put some things that you might want to use if you're a little bit more advanced or you have an adult helper with you. And these are things that you might find in your pantry or your cleaning cabinet or your bathroom, things like baking soda, vinegar, Clorox, bleach, ammonia. All right, so if you're just starting out, I would stick with the things that are on this side that you find on the kitchen. If you want to get a little bit more advanced and you're used to doing science experiments safely, then you can experiment with these over here. All right, so what we're going to do is our two different tests, and I have all my samples right over here. I poured out my samples into 2 cups. The front row has just a little bit in there, and the back row has much more in there. And you'll see why in a second. Let me finish making my samples here. So you can see that my soap sample is the last one that I haven't made yet. So I'm just gonna pour just until it covers that bottom layer for our first test, and almost all of the rest of it for our second test. All right, and we're all ready. If you are doing this at home, I would definitely recommend getting some masking tape, or I used a label maker. You definitely want to label all your samples because, as you can see, many of them are clear. So they're all clear liquids. You can get them mixed up very easily. And in chemistry, it's really important to make sure we're organized about what we're doing. So make sure you figure out a way to label all of your samples. All right, are you guys ready to get started? So here's our cabbage juice. We're gonna test in our front row of samples, and all you need to do is take a little bit of cabbage juice and pour it into the sample. You wanna make sure that you're not contaminating it, so you wanna get the cabbage juice into the cup, but you don't wanna get anything from the cup into here or into another cup. Right, so the way I'm gonna do it today is I'm just gonna use a straw. At home, you can use a spoon. If you have a good container, you can just pour a little bit. It doesn't matter too much how much you pour. You'll see some color changes right away. All right, so we're gonna start off on this end. All right, our first sample is gonna be our tonic water. So I'm just gonna take some sample, put it in there. You guys see what color that turned? That looks like a bright pink. So that's how our cabbage juice indicator works. If we see a color change to a bright pink, we know that our sample is an acid. If we see that it kind of stays purple, our sample is neutral. If we see that it turns a bluish green, then we know that our sample is a base. All right, let's move on. So our next sample is some bottled water. Right, that looks like it kind of stayed purple. We could put a little bit more in if we think our color is not strong enough. Right, that's pretty purple. Our next sample is vinegar. Do we have any guesses? Do we think that's an acid, a neutral, or a base? You might know this one already. Right, that looks like an acid. Our next one is some baking soda. And what you can do is if your sample is a powder, you need to make sure you mix that with a little bit of water. Ooh, look at that. That is a teal greenish color. So that is a base. Our next sample is some soap. This is just some hand soap mixed in with some water, so it's a little bit liquidier. That looks pretty neutral. Nice purple color. Our next sample is ammonia, which we use in cleaning a lot. That is a pretty bright green color, so that's also a base. Our next sample is milk, just whole regular milk. Pretty neutral. There we go, purple. Our next sample is lemon juice. That is quite a bright pink, close to the vinegar one that we had earlier. Our next one is tap water, so we can compare that to our bottled water, see if there's any differences. Purple, kind of bluish, maybe a little bit of a weak base there. And then our last one is bleach. Again, mostly used for cleaning. That is quite a yellowish color. You can see it sort of starts out as green. Right, so that is also a base. All right, so we have a good qualitative test that we did. So qualitative means that we're not really measuring anything. We're kind of looking at what color it is. So it doesn't really matter how much sample we have and how much indicator we put. I usually put about equal amounts so that you can see it. The next test we're going to do is quantitative. So we're actually going to measure. All right, so we're going to get some number results from these. And we're using a pH meter right here. So I have some water that was a 7. We're gonna zero that in. All right, so that way we start off with there we go. So we start off with So while I'm doing this, if there are any questions, I'd be happy to answer.
We have a question here. What does pH stand for?
That's a great question. There's a little bit of a debate as to what the P stands for. Some people say it's percent, which is not actually accurate. Some people say it's potential or power. But the H definitely stands for hydrogen. And we'll talk a little bit later on. We'll go back to our scale that we mentioned. And we'll talk a little bit more about the numbers. But pH basically means concentration of hydrogen ions. Okay, so our water here, which is distilled water, is a 7. So we're going to assume that that's our known value. We already know that. Many scientists have figured that out, and that's what we're going to start with. We're also, our probe is right here. We're going to be dipping this probe into all of our samples. In between each sample, we're definitely going to rinse it off in our water here so that we're not cross-contaminating any of our samples. All right, so start back over here. So our first sample is going to be our tonic water. Did I mess that up? I might have messed that up. Because now our thing is not changing at all. Do you want to look at it?
We also have another quick question.
Sure.
You mentioned litmus paper is made from lichen. Is that a plant?
Lichen is actually a combination of algae and a few other things. So lichen is its own organism. It has some plant-like properties, but it also has some animal-like properties. And that's kind of where it started off being made. I'm not sure if currently litmus paper is also made using the same kind of lichen. But like I mentioned, there's a bunch of other things in nature that tell us whether something is an acid or a base. If you've ever seen hydrangea flowers, if they're blue, it means that the soil that they're in is basic or alkaline. If they're pink, that means the soil that they're in is acidic. So it's kind of a natural indicator. If you just look out and see some hydrangea flowers, we'll know about the soil content in there. So while Mr. Jose is working on our meter, we can go ahead and look at some things over here. Actually, no, let's not do that. We'll wait until we have our meter ready. But what I do want to tell you is these different liquids I've tried before in a few different areas. In school, at science museums, at home, I've had some experience with these. But what I thought was maybe you haven't. Maybe you haven't tried something like this and it's all new to you. So I decided to do something with you that's new to me too. So I decided that I had a question. I looked at my fridge and I said, hey, I have all these different kinds of dairy products. I wonder if some of these are acids or some of them are bases or some of them might be neutral. So I decided to try my own sort of original experiment for me. And what I'm going to be doing, oh, thank you, Mr. Jose. After we do our pH meter test, I'm going to do an original to me experiment, new to me experiment with you, where I brought a few different types of dairy products, and we're going to be seeing if those are acids or bases. So hopefully that'll encourage you to do it if this is new to you. All right, so we have had some technical help with our meter. And so now we want that number to be changing a little bit because it does fluctuate. So we have our water that has a pH of about 7. We're going to move to our first sample here. And that is the soda water. Right, our soda water is more acidic. So it's hovering around 4. All right, so that's definitely an acid. It looks like we double checked and it was pink, so that works. Our bottled water, it's going a little bit higher. Oh, that was almost a 6. All right, so definitely more in the neutral range. Our next one is vinegar. So we expect that to be an acid according to our cabbage juice test. And our meter definitely shows that it is an acid. So it is below a 7. Below a 7 means acid. The closer it is to a 0, it means it's getting to be a stronger acid. All right, our next one is baking soda. So let's try that out. Let's make sure our entire probe is submerged in there. All right, so it is definitely above a 7. All right, and let's move on to our soap. Oops. I touched something. There we go. We're back. And we're going to try our soap. So it is a little bit more basic or alkaline. Our next one is ammonia. So that's definitely more basic. We're all the way up to 11, almost 12. Our next one is milk. Alright, so our numbers are decreasing, which means we're going more towards being neutral, which is what our cabbage juice indicator also shows. Lemon juice. Alright, our numbers are decreasing rapidly, which matches with what our cabbage juice indicator also said, which was an acid. And our next sample is tap water. Right, so we're back in the neutral range here. And then our very last sample is bleach. So if you can see, our indicator has now disappeared because it's bleach, and bleach tends to bleach out color. So I'm glad we looked at it while we still had the pH indicator in there. All right, our numbers are climbing pretty rapidly. So bleach is a pretty strong base. All right, so that was our qualitative test. And our cabbage juice indicator was, or this was our quantitative test, which means we get number results. And our cabbage juice indicator was a qualitative test, which means we get color results. Let's see. Right, we're gonna do our milk experiment. And then while I'm setting that up, I'm happy to answer any questions that might be there.
There's another question asking about cabbage juice and whether or not we can use that as our own litmus paper.
Oh, that's an interesting idea. So what we do here at MOSI is in addition to using litmus paper, we also buy like cabbage juice that's been dehydrated. And so it's a powder, which means we can make a very concentrated solution, and our colors are much brighter and we can get a much better result. At home, if you make cabbage juice and maybe soak some paper in it and try it out, and if that works for you, definitely let us know. I would say that's a very good application to try it out in. I've never tried it, so I'd be very curious to know if that works. I would say you'd need to get a pretty concentrated amount of cabbage juice to soak and dry into whatever paper you're using. So that's a great idea. I encourage you to try it, whoever mentioned it. All right, so here's our milk experiment. I'm gonna take our milk that we already did, I'm gonna leave it right there. And so I have a few more dairy products that we can try. We have heavy cream, yogurt, which is a little gloopy, so I mixed that with some water. And then I also have some almond milk. So we're gonna do the same thing again, 2 different sample cups. And I'm gonna pour a little bit of sample in the first one for our pH or cabbage juice indicator, and a lot of sample in our second one so that we can dip our entire probe in there. Now I'm using some fancy condiment cups and bottles and such. At home, you are welcome to use whatever cups and bowls and stuff you have at home. Like I said, this is a qualitative measurement, so it doesn't matter too much about how much you have in there. So use whatever cups you have and try to use sort of the same amount of sample as cabbage juice indicator. All right, there's our cream. All right, let's try this out. Before we try it out, we can talk a little bit about what we might expect. So we see that milk here is pretty neutral, and we have almond milk, yogurt, and cream. I think, because I know I've tasted some of these before, and from what I see over here, a lot of the things that might taste sour, like lemon juice or vinegar, seem to be acids. So I think that if one of these tastes a little bit sour, then that might be an acid. But I think cream and almond milk kind of taste similar to milk in terms of acidity, so I would expect them to be neutral. A good experiment at home would also be if you tried this on milk that's going bad. Always use things that you would throw away. You can use them for science. All right, so let's try. We're gonna do our almond milk first. All right, so that looks like it's a base, or not a base, it's neutral, it's purple. Let's try our yogurt. It's pretty purple, but it looks like it has some hints of pink, so that might be an acid. And here's our cream. Put a little bit more in. If you have samples that are not all the way clear, try to use samples that are at least light colored. So things like lemon juice and our milks are fairly light colored, so your cabbage juice indicator color will show up. And if you're using other things at home, you can use things like orange juice, a lot of different juices. If you use something dark like coffee, you might not get a good result because you might not be able to tell if something is pink or purple or blue. So that's all I have for you today. Thank you for joining me in Virtual MOSI with our pH experiment, and hopefully you can try some of these things at home. Thank you. Keep discovering.